Okay, so this is the electron between these two plates that produces a uniform electric field in this region of 12,000 Newton per Coulomb. And the separation distance between the plates is 40 millimeters. And the electron starts its motion from the plate A uh, toward, directly toward to the plate B with an initial velocity of 10 to 7 meter per second. So the question is, what is the closest approach of the electron to the plate B? Okay, so first we have to understand the kind of motion, the type of motion that the electron does have between the plates. Well, since the electric field is from plate A to plate B, that means the plate A has positive charge and the electron has negative charge. Although the electron is fired away from the plate A, it will be pulled toward the plate A by the positive charges on the plate A. Or you can view the picture as that since the electric field is toward right, whenever you put a charge object on the electric field, the charge object will experience a force either anti-parallel to the electric field or parallel to the electric field. If the charge is negative, the direction of the force is going to be opposite to the direction of the electric field. So while the electron goes in this straight line, that means it will decelerate, okay? Because the force during its motion, the force is going to be just opposite to the direction of the motion. So that means it will stop its motion somewhere while it's approaching to B. And wherever it stops, let's say this is the stopping point, okay? What is the distance of that point to the plate B? Because it will go like decelerating toward this point B, to this point, let's say P, and it will stop right here and then it will go back. Well, since the type of motion is a constant accelerated motion with speeding down because its initial velocity is given, its initial velocity is just toward right while its acceleration is toward left. So how can we find this distance? All right, thinking that the electron starts its motion right on the plate A. All right. So if we can find the distance it goes, the farthest away from the plate A, we can find this distance from this point to point B because we know what the distance of separation distance between the plates. So if this is the point, okay, that we can find this distance, let's say x, stopping distance. Well, that distance, x, let's say, the distance that the electron goes, can be expressed by this most general expression for distances for a constant accelerated motion, x0 plus v0 times t minus, thinking that the acceleration is negative, 1/2 at square, right? Well, t is going to be that stopping time as the electron goes from this point to this point. Further, you have to find this stopping time, but we have a further equation that in terms of the velocities, and the final velocity squared is equal to initial velocity squared minus 2 times the acceleration times the distance it goes. We have also this equation in the kinematics, right, of one-dimensional motion, because one-dimensional motion, it is a decelerated motion. So this is why we have a minus sign over it, because of the acceleration, okay? Because while it's going in this direction, the acceleration is just opposite. All right. We know at the stopping point that the velocity is 0. We know what the initial velocity is. It is 10 to 7. And we know, do we know the acceleration? Well, we can find maybe. We can find the distance. And the nice thing about this equation is that there is no time for that. There is no time needed to be found, okay? But we can find always the acceleration, because the acceleration for the electron in a uniform field is just the electric field, the charge of the electron multiplied by the electric field magnitude divided by the mass of the electron. So, and when you put this over here, then only unknown in this equation is going to be the x, the distance, all right? So everything is going to be just, the stopping distance, the stopping point, at the stopping point of obviously the velocity is going to be 0. So if you solve this equation for x, x is going to be just v0 squared, the initial velocity squared, divided by 2 times the acceleration. But if you put also instead of the acceleration this expression, that m divided by 2 times charge of the electron multiplied by the magnitude of the electric field. So this is the, in fact, the analytic expression for the distance that the electron goes from the initial point that they plate A to this point. Once you find this distance, and it's easy to find the from point P, the distance from point P to the plate B. So all you have to do is just put these numbers, that 10 to 7 squared multiplied by the mass of the electron is 9.1 times 10 to minus 31. Of course, we have to use the SI unit system. This is kilogram, divided by 2 times 1.6 times 10 to minus 19 coulomb, multiplied by, in SI unit system, we know that the magnitude of the electric field is just 12,000. Okay, so once you solve this, find the x in units of meters, and then the rest is just, subtract this quantity from 40 millimeters to find the distance of point P to the plate B.